Good morning. This is your stats sensei, Mr. Spensei, and I'm going over the quiz. Hope you go through this, and this should help you do well on tomorrow's test. So, the weight of a single MP3 player has a mean of 6 ounces and a standard deviation of 2.5. So we have a mean of 6, standard deviation of 2.5. Suppose a sample of 50, so we have a sample size of 50, so that's our N. MP3 players is drawn randomly from a population of MP3 players, and the weight of each player is recorded. Give the mean and sampling distribution of the mean. Now, this could have said X bar, this could have said average, and it would all have the exact same answer. But this is a very simple question because the mean of the mean is the mean. So the mean is the mean is the mean. That's always the case. In this case, our answer is 6 ounces. Really no work to show on that one. The next one, give the standard deviation of the sampling distribution of the mean. Once again, it could have said X bar or it could have said average and it would have had the exact same meaning. But when we have the standard deviation of the mean, that's our symbol. And here is our formula, which is the standard deviation of the population divided by the square root of the sample size. So our numerator is just simply the standard deviation that they gave us, 2.5. And the denominator is going to be the square root of the sample size. And we already said that that was 50. So if you just gave us that, we would be good to go. 2.5 divided by the square root of 50, or 2.5 divided by 50 raised to the half power is 0.3535. What is the probability that a sample of 30 MP3 players, so we have a sample size of 30, so there's our N, has a mean weight of less than 5.5? So they're asking for the mean and they have a sample size. If they're asking for the mean, we're going to be using z-test. But first off, we have to draw our graph. This will be worth 2 points at least on every problem. So we have a mean, our initial mean is 6 ounces, so we're centered at 6. And we want to be less than 5.5. So that's this way. All right. So z-test. So let's go there first. Stat, test, z-test. We want stats highlighted. And the first thing it asks for is the mean. Well, the mean was 6 ounces, so we need to write that down. So the mean is 6. The next thing it asks for is the standard deviation, and the standard deviation is 2.5. Then it asks for our X bar, which is our sample mean, and our sample mean was 5.5. That's based on our graph. Then it asked for the sample size, and they told us there was 30. And then it asked for the way we're shading. So we're going to be using a less than because we shaded to the left. So let me get all that information into the calculator. So standard deviation 2.5, X bar 5.5, sample size 30. Then we have a less than, and we're going to go ahead and calculate. And that's 0.1366. Now, the way this is scored, your answer is probably worth 2 points, the graph is worth 2 points, and this is probably worth 3. The calculator is stuck. What is the probability that a MP3, so when it says A, that means our sample size is 1, weighs more than 8.5 ounces? So once again, we draw our graph. Our graph is worth 2 points. 8.5 is up here, and we're shading to the right. We only have a single, so in this case, it's going to be a norm CDF, and our lower is going to be 8.5. Our upper is going to be positive infinity. Our mean is 0, and our standard deviation, oops, no, that's not true. It's actual values. So our mean is not 0. Our mean is 6. And our standard deviation is the actual 2.5. So let's pop that into the calculator real quickly. Second vars, norm, CDF, lower part, 8.5, upper part, 9 to the 99th. Oops. Mean, 6, standard deviation, 2.5. And we end up getting 0.1586. Once again, the graph is worth 2 points. The calculator commands are worth 3 points, and the answer itself is worth 2 points. Calculate the actual weight for the highest 6% of MP3 players. Well, they give us a percent. They gave us an app, so we're going to be doing inverse norm. Now, once again, we still have to draw the graph. So 0.06. We're still centered at the mean of 6. Now, I need to be really careful with this because the calculator is always working from the left. So this isn't, I'm not going to worry about the 0.06. I need 1 minus 0.06, which gives me 0.94 because the calculator is always working for the left. So this is going to be an inverse norm because they gave us the app. They gave us percent. So inverse norm, and the very first thing it's going to ask for is the area, which in this case is 0.94. Then it's going to ask for a mean, and since it's actual values, we're going to use the actual mean of 6, and we'll use the standard deviation of 2.5. So here we go. Second vars, inverse norm, area 0.94, mean 6, standard deviation 2.5. Going from the left, and we end up getting 9.8869, and that makes sense because we're up above 6. So our answer, 9.8869. Shouldn't need to tell you this, but always 4 decimal places. All right, 2 points, 3 points, and 2 points. Now it says, what is the z-score associated with the bottom 15%? Well, remember, all z-scores are centered on 0. So this has a center of 0. This is 0.15. That's our area. And they all have a standard deviation of 1. So mean is 0, standard deviation of 1. And since they gave us a percent, we're going to be using inverse norm. Inverse norm, the very first thing it's going to ask for is the area. We're coming from the left already, so we don't have to make any adjustments. So we can just write down the 0.15. All z-scores have a mean equal to 0 and a standard deviation equal to 1. So here we go. Second vars, inverse norm, area 0.15, mean is 0, standard deviation 1. And we end up getting a z-score of negative 1.0364. So I need to ask myself, does it make sense? And the answer is, well, yes, it does, because we're below 0, so we would expect our z-score to be negative. And once again, always 4 decimal places. What is the z-score associated with the upper 9%? So, okay, we have the upper 9%. Again, we make our graph. This is 0.09. But all z-scores are centered at 0. Standard deviation is 1. Well, please remember, we're working from the left, so we have to do the 1 minus 0.09, which gives us 0.91. They gave us a percent, so we're doing an inverse norm. And our area equals 0.91. Our mean is 0. Our standard deviation of 1. And again, we're using 0 and 1 because they're asking for a z-score. So second vars, inverse norm, 0.91, mean is 0, standard deviation 1. And we end up getting a positive 1.3407. And it makes sense for it to be positive because we are above 0. All right. Within what range of actual weights would the middle 75% of z-scores fall? Okay, we have a problem here. This says actual and z-scores. So We're going to do both of them, although you're only required to have done one for the quiz. It should have only had one of those. So actual weight. Well, the actual weight is centered on the 6, and we want the middle 75%. So if they want the middle 75%, we're going to go Z interval. I'll write this here. Z interval. And let's even see what they asked for on Z interval. So second vars, stat test, Z interval. And the very first thing they asked for is my standard deviation. Well, my standard deviation is the one that they gave was 2.5. Then they gave the X bar is 6. And we don't have a sample size, so we're going to have to use a sample size of 1. And they said do it at 75%. So my C level is 0.75. So N is 1, C level equals 0.75. So this one calculated the actual values, and we end up getting the interval of 3.1241 and 8.8759. So there's my lower, here's my upper. All right. Now, technically, I only had to do one of those. So this takes care of my lower here, my upper there. I needed to have this graph, and I also need to have this information here. This was worth 2. This is worth 3. This is worth another 2 points for 7 points. Now, if we had done z-scores, with z-scores, we're looking for the middle. Once again, the middle 75%, but we're working with 0 and 1 because of z-score. So I'm going to go ahead and draw this out. So if I were doing the z-scores and it asked for both, we only needed 1. Z-scores are centered at 1. We're going to need a lower, and we're going to need an upper, and we need to have 0.75 written there, and I should have done the same thing there, which I did. And I can still go to Z interval. It's going to ask for the standard deviation. Well, all standard deviations for z-scores are 1. The X bar, well, it's centered at 0. That's where it's centered at. Our sample size happens to be 1. And then we're going to ask for the C level, which is still going to be 0.75. So in this case, we could go, all right, second var or stat test, Z interval, standard deviation, z-score, it's 1. The center, 0. Sample size is 1. And we're going to get 2 z-scores, a negative 1.15 and a positive 1.15. Negative 1.15 and positive 1.15. Okay? So Z interval works for that. There's another way to do it, but this is probably the fastest. All right, we're halfway done. Actually, a little further. So a soft drink bottle vendor claims that its process yields bottle with a mean internal strength of 157 psi. So the mean is 157 and a standard deviation of 3. A bottler strikes an agreement with the vendor and permits the bottle to sample from the vendors to verify the vendor's claim. Suppose the bottler randomly selects 40 bottles from the last 10,000 produced. Give the mean of the sampling distribution of, and this should, so of the mean, give the sample, so ask for the mean. If it's asking for the mean is the mean is the mean. So this should have been about the easiest problem, 157 psi. No real work to show there. Give the standard deviation of the sampling distribution of the mean. Well, the standard that would be this, but I need to show my formula. And the actual standard deviation was 3. But we have a sample size of 40. So 3 divided by the square root of 40. 3 divided by 40 raised to the half power. And we end up getting 0.4743. Have to have that required. What is approximate probability that a randomly selected bottle, so a single bottle, has an internal strength between 155.8 and 156.5? Well, I noticed that's below 157. So once again, they're asking for a probability, so I have to draw my graph. My graph is centered at 157, and we have 156.5, and then we have 155.8, and we shade in between. Now, in this particular case, where do we go on the calculator? Well, it's either going to be a z-test or a norm CDF, but since they didn't ask for the mean, we use z-test for the means. They didn't ask for that. We're going to do a norm CDF. And our lower is 155.8. Our upper is 156.5. Our mean is 157. And our standard deviation is 3. So here we go. Second vars, norm, CDF, 155.8, upper 156.5, mean 157, and our standard deviation of 3. When we find out that our answer is 0.08923. Once again, 4 decimal places, 0.0892, 4 decimal places. What's the probability that a 120 bottle sample has a mean? So, we have a sample size that's different than 1, and we're looking for a mean less than 156. As soon as we have a mean, we know we're looking for a z-test. All right. Well, the data is centered on 157, and we're looking for an X bar of less than 156.6. So with that case, because it's a mean, this is going to be a z-test. And it's going to ask me for the mean, which is 157. It's going to ask me for the standard deviation, which is 3. It's going to ask me for the X bar, which is 156.6. And it's going to ask me for my sample size is 120. And we shade it to the left. So here we go. Stat, test, z-test, mean, 157. Standard deviation, 3. X bar, 156.6. Sample size is 120. Calculate. And we end up getting a z-score of 0.0720. So that's my answer, and I need 4 decimal places, 0.0720. This is worth 2 points. That's worth 3 points. This is worth 2. What's the probability that the mean, we're asking for a mean, internal strength for a 20 bottle sample exceeds 158.1? So once again, we are centered on 157. We want 158.1, which is up here. We're shading up. So since it asks for a mean, we're looking for a z-test. And the mean is 157. That's where we're centered. Standard deviation is 3. X bar in this case is 158.1. We have a sample size of 20. And we shade it up, so we're going to use the greater than. So stat, test, z-test, 158.1, 20, and we need to shade up this time. And we end up getting 0.0505 for our probability. I know this is old, but this is worth 2 points. That's worth 3 points, and this is worth the other 2. What are the z-scores associated with the middle 94% of the data? You must give both the upper and lower bounds of the interval. All right, so they're asking for a z-score. So with a z-score, all z-scores have a mean of 0 and a standard deviation of 1. So we know we're going to be centered on 0, and we're going to have a lower and an upper, and we need 0.94. So I can go to z-interval. Now, it's not the only place I can go to, but I can go to z-interval. Let's see what they ask for. Sat test. And scroll down to z-interval, which happens at number 7. And it asks for the standard deviation. Well, what was the standard deviation? Standard deviation is 3. But we're looking for z-scores. All z-scores have a standard deviation of 1. And they're looking for the x-bar. Well, where is it centered? It's centered at 0. Our sample size, it didn't give us 1, so we're looking for 1. And we're looking for a C level equal to 0.94. So I should get 2 z-scores, and here we go. Standard deviation 0, standard deviation of 1, centered at 0, sample size of 1, because they didn't give it to us, and then 0.94. And I end up getting negative 1.88 and positive 1.88. And 1.8808. All right. So there's my lower bound, and here's my upper bound. All right, a survey is planned to determine the mean annual medical expenses of employees of a large company. A pilot study indicated that the population mean is 1,240. All right. And we have a standard deviation of 235. What's the likelihood a person, so that means 1, spends more than 1,430? All right, we're centered at 1,240. We want 1,430. So they're asking us for a probability. All right, their likelihood means they're asking us for a probability. So this will be a norm CDF. The lower is going to be 1,430. The upper is positive infinity. Our mean, 1,240. And our standard deviation is 235. So second vars, norm CDF, lower 1430, upper 1240, mean, upper 9.99, mean 1240, standard deviation 235, and we end up getting 0.2093. 0.2093. I'm not very confident that I typed those numbers in. I made so many mistakes. I want to recheck that. So second vars, norm CDF, 1,430, infinity, 1,240, 235. Looks like I did it right. That's good. 0.2093. All right, so moving on to the last problem. What's the likelihood a simple random sample of 60 people will spend less than 1,200? So what is, on average, what's the likelihood that they would spend that? So we're looking for the likelihood that the mean is less than 1,200. So anytime we're looking for a mean, we're going to be looking for a z-test. So in this case, we're centered at 1,240. We're centered at the actual value. We have a value of spend less than 1,200, so that's over here. We have to spend less. And we have a sample size of 60. So we're going to go to z-test. It's going to ask us for the mean, which is 1,240. It's going to ask us for the standard deviation, which is 235. Then it's going to ask us for the X bar, which is 1,200. And it's going to give us a sample size of 60. And we're shading to the left. So here we go. Stat, test, z-test, mean, 1,240, standard deviation, 235, X bar, 1,200, sample size, 60, shading left, and we end up getting 0.0936. 2 points, 3 points, 2 points. If you have any questions, Mrs. Reisinger and I will be in our classrooms Tuesday morning, and we can help you out. Hope this helps you out with your test, and I will see you on the next one. Thank you.